What up, ladies and gentlemen? I just finished grading the first exam, so your grades are going to be in there. Here we're going to do we're going to go over it. So if you guys want to see exam 1 again or see the solutions rather, here are the solutions. This is going to be all of them. I'm going to just add the 10 points in the final grading. So your Moodle grade is going to reflect what you actually got, right? So if you got an 80, then your Moodle grade is going to say 80, and then when I go to do final grades, it'll be a 90 in my grade book. So don't worry about that. If I get any emails saying, hey, John, did you add the 10 points? I'm going to be super upset because that means that you didn't watch this. Please watch it. Pretty please. Okay. Alrighty. So the first one, right? We know that it's irrational, so this just means that the bottom can't be 0. So we know that it's going to be any real number except for 0. Here, sine of pi x, because sine is continuous, we can just go ahead and toss that limit in there, right? So x, the limit of sine is going to be the sine of the limit. This limit can just go in because sine is continuous, which means that as x approaches 2, this guy is going to be sine of 2 pi. And you need to know that that's 0. Compute the following limit here. So x squared over x, of course, at 0 is not defined because we're dividing by 0. But x squared divided by x is just x, right? So we know that this function here is actually going to just look like this. X squared over x is just y equals x with a whole at 0, because 0 is not defined. But everywhere else it's defined. If you take x squared divided by x, this is just x for x not 0, right? If x is 0, it's not defined. We don't know what 0 divided by 0 is. So this guy here is going to be, the limit here would just be 0 because the limit of x there is 0. What is the limit of this following function? Well, we look at x squared plus 2 as it's approaching 3. So we got to check this guy at 3, check this guy at 3, and then, oh, this was perhaps, I should have said the limit as f approaches. I apologize for the wording on this. So if anybody, I mean, it should have been clear with what we were asking, but that's not clear. Reach out to me and I can look back at your. Okay, so x plus 2, or x squared plus 2, we plug in at 3, and this is going to be 3 squared plus 2 is 9 plus 2 is 11, right? That's the left-hand side limit. The right-hand side limit is just 3 plus 8, which is also 11, which means that our guy here is 11. Now the question, true or false, the following function is continuous. Well, to be continuous, we know that our function looks something like this. We know that the limit of this quadratic part is like this. This guy's 11. And then we go like this, it's linear afterwards, right? So we know that this guy, the limit is 11. The question is this an open hole with this somewhere else, or is it actually filled in here, right? So we need to justify that the limit is the same as the value. So what is the limit of this? Well, we already solved that it was 11. What is the value? It's 10, right? So that is not the limit. So as we're getting closer to this point, right, we're getting close to 11, but it's actually defined at 10 right here. So that would not be true. Not continue. Okay, go to the next page. Here, a lot of people, what you ended up doing was just plugging in 0. You're like, oh, the limit, the limit of x sine x is just going to be 0 sine 0, which is 0, right? This is fine. I didn't expect it. I meant for this to be squeeze theorem, but you can actually just plug it in here. But you have to be careful because x is continuous, and so is sine of x. So therefore, x sine of x is continuous, right? The product of two continuous functions is continuous. But the issue that we are getting here is that people were just saying this, and they're like, we're straight. You can't always just plug in the number, right? You have to make sure that it's continuous, right? The same way that on this last question here on number 5, we can't just plug in, what is the limit of this function? The limit is 11. So we can't just plug in f of 3 because f of 3 would be 10, right? So that's where you have these issues. So we can't just plug in x sine x, plug in 0 here because we don't know. Maybe x sine x is like that last function where the limit is 11, but the actual value is 10. Of course it's not. We know it's not because it's a composition of continuous functions, but we have to state that. Or we could also use squeeze theorem. We say that -1 is less than or equal to sine x less than or equal to 1, which means negative x is less than or equal to x sine x, which is less than or equal to x. right? And by squeeze theorem, both left and right limits are 0, which means the middle limit is 0, right? So either of these ways, you would get the limit of this guy would be 0, right? Okay, let's see. We go down here, we find the equation of the tangent line. So here, tangent line, we have to make sure that we're finding the slope and then actually finding where it intercepts, right? So here I was giving points for like finding the slope or doing like a limit definition or a derivative. You could do either one. You could do the limit definition of the derivative, like f of x plus h minus f of x over h, or you could just do your product rule. Either way is fine, or power rule, either is fine. Then you're getting points for having the correct slope, so you plug it in, then points for the correct intercept, and then finally points for the correct line. So here, if we go in, we're going to say f of x equals x squared plus 4, and so this function is going to look something like this. It's going to look something like this, right? Maybe it's going to be like this. And then this is our point here, 2, that we're looking for. So we need to find what the slope of this would be and then actually construct a line using the intercept formula, right? So here, what is our slope? Well, f prime of x is going to be 2x plus 0, right? The derivative of 4 is 0. And so then, and you could also remember, you can do derivatives because derivatives are going to be easier. But if you wanted to do f of x plus h minus f of x over h, you could also do that. I'm not going to do that here, but if you want to do that, you can look back at one of the previous problem sessions I did, and we had a problem like this where it's a quadratic, and you can just go ahead and do it. There, you would have to make sure that you're saying, let me go down. There, you'd have to make sure that x plus h squared is x squared plus h squared plus 2xh, right? And you divide, you do your things, and you're fine. Okay, so f prime of x is going to be 2x, which means the slope of the tangent line at x equals 2 is f prime of 2, which is 2 times 2, which is 4. Okay, so now our line will be of the form y equals mx plus b, right? And some people did the slope. You know, you can find this it's just algebra. You can find this line equation any type of way you want. We know we know that f of 2 is going to be 2 squared plus 4, which is 4 plus 4, which is 8. So the line must pass through our point 2, 8, right? This means that y so that means that plugging in this point, we find y equals 4x plus b, which is 8 plus b, so b is 0. Therefore, our line is y equals 4x plus 0. You can just omit the 0. So y equals 4x is our tangent line here. And if you go on Desmos, right, we can pull up, not that you would have this capability on the test, but yeah, we have y equals x squared plus 4, and then we have y equals 4x. And we notice that this is a tangent line intersecting at 2, 8, right? Cool. Whoopsie. That. Finally, we've got epsilon definition. Epsilon definition. When you're doing epsilon definition, always say, let epsilon be greater than 0. Let delta equal something. We're going to do that later. Okay. So we say, we're going to say, let x minus the limit be less than delta. We want to show f of x minus L, which is, f of x minus L is less than epsilon, right? So here we compute f of x minus L. This guy is going to be, what? Well, f of x is going to be x plus 4. What is L? It's our limit, which is 7, right? And this guy is x minus 3. We want this to be less than epsilon. And we notice that, I wouldn't write this. So we notice that we want x minus 3 to be less than epsilon, but we know that x minus 3 is less than delta. So if we just say let delta equal epsilon, then we see that x minus 3 is less than delta, which equals epsilon. So the proof is complete, right? Make sure that this is a super, epsilon definitions are super difficult to do if you don't follow this process of like let epsilon be greater than 0, let delta equal epsilon. Even if you get the right, a lot of people are getting the right ideas, but there's an issue in the logic. If you actually read through the proof doesn't make sense. Like I see that you got all the pieces. We got to make sure the pieces come together cohesively. Because if we said something like let delta equal epsilon down here, well, this is not true because you're saying that x minus 3 is less than delta. This is true, but it's not equal to epsilon. You let that equal it afterwards, right? So it's not like this is an idea of a type of answer I was getting a lot, where it's like kind of getting there, but you're missing just a little bit. So this here would be a complete proof, and then that would be our exam, right? So if you have any questions, please feel free to email me. Once again, I apologize for not having test day go well. It will be good in the future. A lot of people are saying that the practice exam wasn't open. Once again, watch the video for that. But I will have the practice exams open in the future. Just a lot of stuff kind of that I should have done better, and I apologize for that. And I hope that the 10 points and the opportunity to do the makeup exam will kind of mediate that. But, once again, I really am sorry for that. And I hope that you all have a wonderful day. Email me if you have any questions, and I'll see you in the next one. Peace.